Do we have other questions? Anything else? Okay, so in that case, I'm going to continue with the last section of this chapter, which deals with implicit differentiation. That's section 2.8. And you can stop me if you remember anything that you want me to work on. Please stop me anytime. So this is related rates. And implicit differentiation. Okay, we're going to start with implicit differentiation. This will come after. Okay, what is implicit differentiation all about? What do I mean by implicit? So if I'm given, let's say, f of x is 2x cubed plus 4x, I can directly find the derivative as 6x squared plus 4. That's direct. Direct. I have the function. I can also be given y, let's say, y equals 4x squared plus 1. Same thing. I can use the notation y prime. I can use the notation f prime. I can use the notation dy over dx. Any of these. And I still get 8x. All of them there are the same. And in this case, it's direct differentiation. Again, this notation is the Leibniz notation, and this signifies, it's very important notation, signifies that y is a function of x. And we looked at it several times, especially last time when we basically decomposed it in two different pieces. This has a meaning, this has a meaning, and the dy is this product, f prime of x dx. Okay, what is implicit? Implicit means basically that I do not have the function. I'm given an equation that has y. Y or f of x mean the same thing. So, for example, y to the third plus 2x squared y equals 4x cubed. As you see, I do not have y equals, which is f of x. I don't have it. If you want me to solve this, I will say sorry. For y, I'll say sorry. I probably have to put it in a software, mathematical software, and it will take probably 2 pages. I don't know how to solve this. But I can determine an expression that represents dy over dx. I can. That is possible. It will depend on y. But it doesn't matter. I still will be able to determine an expression for the derivative of y that I don't even have. Again, it will be function of y. Because this I could evaluate, let's say, for x equals and y equals. So the idea is I'm not really interested to find y here. I cannot even do it. But I will be able to find an expression for its derivative that I can evaluate for a point that is on this equation. Not a point out of the equation, a point that verifies the equation when x is whatever y equals the other one. And I will be able to say that, let's say, something that happens or I'm interested in on this equation has the instantaneous rate of change, blah, 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 depending on the numbers I plug in. So let's look at this and see how we find that dy over dx. Again, this implies that y is not a variable, but y is a function of x. So this is very important notation. And you'll say, why don't you use y prime and you use this notation? Because this one is safer in such a situation. So I don't, if I miss this little thing up there, I may not be able to solve. I may get something else that it's incorrect. So I just made up that problem, and then we'll choose the problems you want to work on. So remember when we solve radical equations, for example, the square root of x plus 1 equals 4. What do we do to both sides to solve for x?
Square.
Excellent. And we take it from there. The same thing here. We're going to differentiate both sides. So when I differentiate the left-hand side, I have to start with y cubed. But y is a function. So can anyone tell us how to differentiate y cubed as a function? What will I have to write?
3y squared y times y prime.
Very good. It's okay. Of course I'll allow it. I don't mind at all if you want to write y prime. It's not safe, but that's what it is. You're right. You can write y prime. Plus, let's leave 2 outside, and remember this is a product now. Function 1, function 2. Can anyone help with that? Other than Nick. Anyone else? Please, anyone? I heard from Kirsten and Megan so far, and Nick. Anyone else?
The x squared dy dx.
Careful. So 2x.
Just 2x. Yeah.
Yes, times y plus x squared dy over dx. Awesome. Perfect. And then on the other side, can anyone give us that? Thank you, Liam. Anyone?
12x squared.
Thank you very much. That's it. So remember, what is our variable? This is our variable. This is what we are trying to solve for. Of course, I will distribute first. So I have 3y squared dy over dx plus 4xy plus 2x squared dy over dx equals 12x squared. This term will stay. This term will stay. But this one will have to move to the other side because these 2 terms have the variable. This one does not. So we will move to the other side. So now let's continue. Stop me if you have questions, please. So then I have 3y squared. I will also factor dy over dx because I cannot combine these 2. So plus 2x squared dy over dx. And this with minus 12x squared minus 4xy. How do I solve for dy over dx? Final step.
You divide.
Yes. Dy over dx equals all this over all this. So 12x squared minus 4xy, 3y squared plus 2x squared. And now you can say, yes, what did you accomplish? Not much. A lot. Yes, I know it has y in it. I cannot solve for y. But if you say evaluate it for x equals and y equals, I will be able to give you the instantaneous rate of change of the original equation when x is and y is. So this is how we deal with with implicit differentiation. So where am I? Where is my book? I can see my book. I got it. Okay. So you want to go to 279. 279. And let's choose any dy over dx, finding a dy over dx without solving, because most of the time we will not be able to. Sometimes we can. And then find the slope of the curve at a given point. So any function or non-function, 1 through 14. We can also look at 15 through 22. We can also look at 23 through 32. And then we'll choose a word problem. And then I would like to talk about related rates. You choose.
We do 13.
13. Very good. Perfect. So let me copy it and then I'll stop sharing. So 13. And that is x squared y minus 2x. Oh, of course I'm copying 14, right? You're not surprised. Minus y to the fourth minus 3y plus 5x plus 1 equals 0 at the point 1 comma negative 2. Perfect. Let me make sure it's 4x cubed. Yes, 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 yes. Perfect. Okay, so we are given an equation. We are not going to solve for y, even if we can, and we cannot. So we're asked to find the equation of the tangent line to the graph of whatever this is at 1 comma negative 2. So I have y minus y1 equals the slope times x minus x1, where x1 is 1, y1 is negative 2. So the only thing I'm missing is this. So this will be nothing else but dy over dx evaluated when x is 1 and y is negative 2, according to the given point. So I will differentiate the left-hand side. I will differentiate the right-hand side, get dy over dx, plug this in, get the number, finish up the equation. Should I repeat the steps? Any questions on the steps?
Yes, please.
So we know the equation of the line with a given a point, right?
Right.
So I plugged in the point, but I'm missing the slope. The slope is the same with dy over dx. And it will be evaluated when x is 1 and when y is negative 2. In order to determine dy over dx, I will differentiate implicitly, both sides. Once I get the number, I will plug it in. Is that better?
So to find the m, I just plug in 1 for x and negative 2 for
Only when we
y,
determine dy
equals to
over
0.
dx. We don't have dy over dx yet. I have to find dy over dx. And then I
Okay.
will plug it in. Is that okay?
Yes, it's clear.
So we differentiate 4x cubed, and we get 12x squared. We differentiate y to the fourth. Can anyone differentiate y to the fourth?
It's 4y cubed.
This is a function times dy over dx times the inner function prime minus 3. What do we write for y prime?
dy over dx.
That's it. Very good. Thank you. And plus 5x prime. That's it. And 1 prime. Anyone? 1 prime?
0.
Very good. And 0 prime? Thank
Also
you.
0.
Very good. So these two terms will go to the other side, and I will factor out dy over dx. So 12x squared plus 5 equals 4y cubed plus 3 dy over dx. So one more time, I kept this here and this on this side. Because these were negative, I moved them to the other side and would change, I would have to change their sign. So I have 4y cubed plus 3, and I factored out the variable. This is the variable. Again, if you want to write it as y prime, it's fine too. So now how do I determine dy over dx? What will be the next step? Anyone?
Do you divide 4y cubed plus 3 to the other side?
Yes. Excellent. Very good. So now all I have to do is just plug in 1 and negative 2 respectively. It was 1 and negative 2, correct. Okay, so 12 times 1 squared, which is 1, so 12 plus 5 is 17. And here I have negative 8. 4 times negative 8, negative 32, and plus 3. Correct my numbers anytime. So this is negative 8. Yes, so this will be negative 17 divided by 29. So now I have everything, including negative 17 divided by 29. So y minus negative 2. So that is y plus 2 equals negative 17 over 29 multiplied by x minus 1. We have to solve for y. So I will distribute negative 17 over 29 x plus 17 over 29. This is positive. It will be moved to the other side, simply changing its sign. I have to find the least common denominator, which we know is 29. I need to multiply this by 29 because it's over 1. So here we have 17 minus 58. 17 minus 58 is a negative number, and I think it's 41 over 29. So the final equation, correct or any number. Please make sure that I'm correct. 29 minus 41 over 29. What does this represent? It represents the equation of the tangent line to the graph of whatever that is at this point. Any questions? It was a good pick, a lot of work, but that's what it is in this class. It's a lot of work.